in this occasion, we will be plotting the orbitals that are generated by NRLMOL. So to do that, first of all, you have to request the calculation of these orbitals. So in the NRLMOL underscore input.dat file, you have to set this option, WF grid V, equal to yes. Normally it's set to no. So once you do that and the calculation actually converses in the SEF cycle, some files will be generated in the directory. Let's go back to the tcnit directory we've been running previously. And these WF homo files will be generated. There's several of them generated. So let's go over what they actually mean. And let's go back to the presentation. And the first file, the one in the middle here, WF homo 00a that cube, is actually the homo level orbital. WF homo 001 will be the one above it, which is LUMO, and from there on WF 02 LUMO plus 1, and so forth all the way to WF homo 10. Okay, going below the homo level, there's WF homo minus 01a, which is homo minus 1, WF homo minus 2, which is going to be homo minus 2, and so forth until WF homo minus 10. The A there just represents the spin. So for a spin polarized calculation, you're going to have WF homo 00A or B, and they can be intertwined. Okay, so in order to plot them with the GUI, all we have to do is just go to the JMOL viewer and open the cube files. So let me go now here to my GUI directory and run it with java -jar NRLMOL GUI.jar. Once this open, I have to set up the current working directory, which will be my tcnit directory again. Once this is set, I can now go ahead and go to the viewer, the JMOL viewer. Okay, now I will just going to open one of the files. I'll open the homo level orbital. So this will be WF homo 00a that cube. I do that, and this opens. Here I can just stretch out the window a little bit, and as I do, I click plot isosurface. So in this case, you select what color you want. In this case, this being a homo level, let me select blue, and let me set up a cutoff value of this much. You press OK, and as you can see, that creates this, the orbital at the homo. You can rotate it and set it to whatever orientation you want. And once you're ready to save it, you can do export. You can save as a POV RAY files, PNG, or JPEG files. You just put the file name, the extension will be added automatically. Now let's close the viewer and use the LUMO level. In this case, I go back to there, go JMOL viewer, open WF homo 01 for the LUMO level. There. Again, I click on plot isosurface. Now, this being LUMO, I want it to be red. I use the same cutoff value, press OK, and there it goes. So you can also rotate this to whatever is better for you. Just press export, give a file name here, and that'll export the file out. Okay, now let's close the GUI, and to do this directly from JMOL, all you have to do is, well, first of all, let me go back to my tcnit directory. There's the WF files. So you open one of them. In this case, let me open WF homo again 00a that cube. That opens it with JMOL. You can see that it just shows the structure. In order to plot the orbital, you have to go to the file in console. Okay, then you type the following command. Isosurface, give it a name, in this case homo, cutoff, let me give the same value as it did in the GUI, there, and then between double quotes the name of the file, WF homo 00a dot cube, press enter, and that creates the isosurface, but as you can see, it's actually purple. So in order to change the color, you type this other command, color isosurface, in this case blue. There, now that turns it blue. In order to save this file, for posting in a document, you go File and Export. You can export the image, or you can render it directly with POV Ray. Okay, in this case, let me do Export Image, and that creates a JPEG image of this file. If you want the background to change, you just do Color, Background, in this case white. That changes to a white background, and you can export it. Now let me just re-export it, and there, I'm gonna overwrite the previous file. Okay, so this is fairly straightforward. So this concludes this section.